Okay, so we're going to do a quick overview of blockchain systems, and then we're going to go into the details of what's underneath them. Good. Okay, so why do we offer a full blockchain course to you? Well, in a sense, it's to avoid this. And there is a lot of this going on. This is a Dilbert cartoon. And there's a lot of misunderstanding about what blockchains are. And so at a minimum, you should come out of this course understanding what a blockchain can and cannot do. And that's important because there's going to be a lot of money that's completely wasted on this stuff. And hopefully it won't be your money. It'll be someone else's money. And the other reason that we finally decided to offer this was to maybe take advantage of this. This is from a couple years ago. Another Dilbert cartoon. This is what's been happening over the last several years. Because of the previous slide, this slide exists, where people are throwing money hand over fist and throwing it at people like you. So if this is, in fact, is the way for you to get your very first job out of here, then yeah, I'll play the game. It's a means to an end. But you should be aware that unlike a lot of the other courses that I teach in this curriculum, I don't know the longevity of the things that you're going to learn in this class. I really don't. And I think people are beginning to understand. Yeah, there might be some things that are gonna fall out in the next maybe 5 years where this won't be such a hot thing anymore. And so I would suggest that we want to play the long game because my first job came in around there, my first full-time job. Does anyone know what this is a picture of? This is the dot-com bubble where you could say internet, 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 and get lots of money. And so I got a lot of money here, and then I lost it because of that, because of a buzzword. And hopefully you have learned some skills along the way that allows you to keep on having a job on the other side of this. The first thing I want to talk about is the blockchain abstraction. So we're all computer scientists. The power of computer science is building abstractions to manage the complexity of computing systems. And we have abstractions everywhere in computer science, and the blockchain is no different. And it's really important for you to understand the abstraction so you can filter out all the noise that's out there. There are several ways to think about blockchain as an abstraction. The first one is this one, where it's a shared database stored in multiple copies on computers throughout the world. And it's a consistent one. Everyone's got the same copy. And it's potentially maintained without the need of a central authority. There is no one in charge of the integrity of that shared database. That's a powerful abstraction if you can use it, right? And this is where people with this abstraction are building lots of different things on top of it. Another definition, a replicated and consistent, immutable, append-only data storage system resistant to tampering. This is a little bit different than number one because it gets at this immutable, append-only idea. So it is a database that never forgets. Every single transaction to that database is recorded so that you can't tamper with any of the state after the fact. Okay, so that's what definition number 2 gets at. Definition number 3, write-only, decentralized state machine that is maintained by untrusted actors, secured by economic incentive. So this gets more at who is managing the state, and the fact that it's not just a data storage system, it's actually a state machine that you're storing. So this allows you to have a system in which data can't be deleted. Well, these are features of what this state machine has. You can't delete data on it. You can't shut down or censor the state machine. Supports defined operations agreed upon by the participants. So there's an instruction set that each one of these participants knows how to execute to transition states. The participants may not know each other, and this is for public blockchains, and we'll get to the definition of those later. And the incentive, it's in the actor's best interest to play by the rules. All the participants in that blockchain are financially tied to each other in a way that promotes pro-social behavior. So that it promotes you playing by the rules, because if you don't play by the rules, bad stuff will happen to you, or bad stuff will happen to the blockchain, and everybody loses their value out of it. Okay? Okay, so how is this being done? And it's being done with a whole bunch of fundamental contributions from computer science. The first one is digital signatures, so public key cryptography. And this provides authentication of all of the requests going into this shared database. You have to validate that, yes, different transactions were actually sent by specific people. So that's one thing. And we'll get to the cryptographic underpinnings in the next class. Cryptographic hash functions. And so the hash chain that we'll be talking about next class, this is a way of making sure that the data that you insert into this database can't be tampered with. And so this gives you the tamper-resistant immutability. Replication. So full copies have to be stored everywhere. What is the way you replicate this in an efficient manner, in a way that, that has low latency? And that's what the replication piece provides you. And this provides availability. You cannot take this thing down. Because there are so many copies out there, it is hard for one country to say, all right, I don't want anyone using Ethereum or Bitcoin in my country. I'm going to shut the whole thing down. Well, they can't shut the ledger down, is a thing for everybody. There's no central control over who can take the blockchain up or down. Then, as soon as you have replicas, you have the issue of making sure you can come to a consensus of what that replica should say, right? Like, who gets to decide what the authoritative copy that everyone has to replicate is? And this is the distributed consensus problem. And this is a very classic problem in distributed systems, distributed agreement, and we'll talk about that next week, the CS behind distributed consensus. And this gives you integrity so that people can't, so a malicious actor can't just join the blockchain and then start changing the state of the replicas willy-nilly. We'll talk about how it gives you that integrity, and decentralized control. How do you get agreement between a bunch of people who might not know each other or trust each other? Okay, I'm going to give you an overview of the kinds of blockchains that we'll be looking at. The first kind of blockchain, the difference in terms of the blockchains that we'll be looking at, are those that simply implement a transaction log. And this is what Bitcoin is doing. It has very limited computational functionality. The nodes on the Bitcoin blockchain, they don't compute much of anything. There are some small validation scripts that they'll execute, but pretty much the only thing that's stored on a Bitcoin blockchain is transfers of Bitcoin back and forth. So it's the simplest one. We're not going to do much with Bitcoin in this class, but it's really good for ledgers. So this is what it's being used as. So if I want to send, A wants to send money to B, A signs a transaction that says it intends to send that money. It's sent as a block, and the block is then broadcast to everybody in the network. And those in the network that can validate that A actually did provide a proper signature for this transaction, they'll validate this block, and then they will replicate. They'll agree that this is a valid block. They'll replicate it everywhere, and then this state, which is your ledger, this chain of blocks, will then show that the money has moved from A to B. Okay? So that's the transaction log. The other kind of blockchain is a Turing-complete blockchain, which is what Ethereum is. And this is a blockchain that can solve any computational problem. So rather than just being a transaction log, it's like an instruction log. And the instructions are like you have a global shared computer, which is basically what every node in Ethereum, the abstraction that it provides. And it's basically a log of state machines, state transitions and state machines on the blockchain. So much more powerful, but also hard to scale. And we'll get to scalability issues, which is why your thing is due on Friday night. Because I can imagine with 50 of you hitting the blockchain Friday night trying to do your homework, that, yeah, the thing might slow down. So yeah, it treats the blockchain as a single global replicated consistent computer. And the entire state machine is executed on every single node in the blockchain. Okay. Another delineation between blockchain systems are those that are permissioned and those that are permissionless. The permissionless ones don't require any permission to join. There is no central authority saying, yes, you can participate, or no, you cannot. Everyone's allowed to use it and create accounts. So this is what you'll be doing on Ethereum. You'll be creating your own account on Ethereum, and then you'll start to use transactions against it, and nobody is there to approve a new account on it. Everyone on a permissionless blockchain is untrusted and potentially malicious. The examples of this are both Bitcoin and Ethereum, which we'll get to later. The other kind are permissioned blockchains. And a lot of the financial and the insurance and the healthcare industry folks are looking at permissioned blockchains. And for these blockchains, only selected authenticated users can participate. And you'll see, because you have a little bit of trust bootstrapped into this system, you can do a completely different kind of system that does distributed consensus and replication. All of those parameters that we talked about earlier can be done differently as soon as you have this, which is, you'll get to see a little bit of this in the Sawtooth labs, but it makes things a lot easier, is effectively it. Okay. One of the nice things about permission blockchains is that it gives you that immutability while still supporting data privacy. Like all the transactions you put up on Ethereum and Bitcoin can be seen by me. But if you're running a permissioned one, then obviously you can keep some of those things secret. Okay. But one of the things that you have to stop and ask yourself before you decide to use a blockchain, and the one thing that hopefully people who are spending a lot of money are going to ask themselves is, why not use a regular database? What is it about my application that requires me to eschew these databases that are really well studied and really well known? And so, well, you know, maybe I need the replication piece. Maybe I need the availability. Maybe I want the anti-censorship. Well, if you want that, well then what about these distributed databases? Maybe Cloud Spanner or Amazon Aurora are all you need, or Amazon RDS replicated across multiple availability zones if you've taken the cloud class. That could be a great solution for this problem. Or hosted data warehouses, and that, so things like BigQuery and Amazon Athena, these are replicated distributed databases that you could also use for your application. What is it about your application that really needs this blockchain? Well, maybe you need the immutability part, right? You need the hash chain so that someone can't go back and tamper with your data store. Well, then you could use ledger databases. So AWS has this QLDB database. You could use Kafka. So Kafka is a system of transaction logs that you could use that you could basically provide cryptographic checksums on all the transactions, and then that makes it immutable. So you could skin that cat any number of ways. So why are you using a blockchain is the question, and we'll get to that. We'll get to the answers in a bit. You could use your Git repositories, right? Like and this is unfortunately the people are like accidentally pushing their AWS keys up onto Git. trying to remove them, and lo and behold, it's still there for everyone to see. Well, yeah, why don't we just use Git to make sure that, well, you can actually delete your entire Git repository. But that's the idea. It's like you could actually log all the commits, all the transactions to your repo, and then somebody could scan Git and then just pull all those transactions. That seems like a pretty good blockchain-ish application that you don't need a blockchain for. Another one is the Internet Time Machine, right? Like that stores everything. You can't go back in time and say, no, my website looked like this in 1999. That doesn't work either. So thinking about whether or not you really need it is something that that's why I'm going through this now. There's this great paper, and I have this linked off of the website. So one of the things I did not mention about the website was that I have some interesting readings that I would suggest you either read or listen to. And so for this week, that paper, Do You Need a Blockchain? It's a very short read, but it's really interesting. So that's there. The other link that I have there is this Polyswarm podcast. This is a startup company that got funded using an ICO on Ethereum. And what they're doing is they're using cryptocurrencies to reward malware analysts, like hobbyist malware analysts, or even sort of industrial malware analysts are being rewarded based on whether or not they can correctly identify malware. And this is an interesting use of the Ethereum blockchain that I wanted you to listen to for enrichment. Okay, so this is one of the flowcharts in that paper. You go through this flowchart, and wherever you end up is the kind of blockchain system that you need. So the first thing, do you need to store state? If that's a no, well then you don't need a blockchain. If that's a yes, then are there multiple writers? If there aren't multiple writers, then you don't need a blockchain. You could just set up a website. The one writer can set up a website and then put it on a cloud provider to massively distribute it. Can you use an always online trusted third party? So if it's yes, then you don't need a blockchain. You have put your trust in that always online trusted third party, or if you're required to. So for a regulatory piece, if your application always requires you to go to, for example, the DMV to validate a record, or some trusted third party must always be consulted before you do anything onto that blockchain, you don't need a blockchain, right? Because then you've already centralized the authority on your application. If the answer to that is no, then you're in business. Then you might be able to use a blockchain. If all the writers are known, then you have this next question, are all the writers trusted? And if the answer is no, then the other thing is public verifiability required. So you can't trust the writers, you know the writers, you can't trust them, and you need public verifiability. This is where we're going to talk about public permission blockchains. So permission means that you can restrict the public means that you can actually, you publish the results, but then you restrict the set of writers in the permission blockchain. If the writers are all trusted, then you can just use a back-end database system. Like all the trusted writers can then just write to the database, and then you don't need to use this blockchain at all. Okay. If you don't know the writers, then you're on the top thing, the permissionless blockchain. And that's where the Ethereum and the Bitcoin are, where none of the writers are known and none of them are trusted. Okay. Okay, so I like doing examples rather than doing a flowchart. So if the parties are known and trusted, you don't need a blockchain. You can use the databases. That was that bottom right path. And you'll see that there are a lot of proposed uses for blockchains that basically fall into this category. If the parties are known and trusted and you also need immutability, you don't need a blockchain either. And so these are the things like QLDB and Kafka that you would use instead. And they're much simpler from a developer standpoint to get running, right? You can meet all of the demands of your application without setting up a backend that's extremely complicated. If all the parties are known but untrusted, then that was the public verification thing. You can either use a public permissioned or a private permissioned blockchain. Okay. The only time you would need a permissionless blockchain, like Ethereum or Bitcoin, is if you need to, or like Ethereum, is if you need to store state and you have multiple anonymous writers that can't agree on a trusted third party. And that is bootstrapping trust in a distributed system. That is something that the permissionless blockchain has solved for us. Okay, so that's the overview of the kinds of blockchains that are out there. We're going to talk about applications. So one of the things that I like to do at the beginning of all my classes is to motivate why you're actually doing this work. And so the applications are what would be motivating the use of blockchains. So the targets for a blockchain are these applications that require this shared common append-only database, applications with multiple participants, so and participants that don't necessarily have a lot of trust amongst themselves, applications that have to run in a distributed manner. If all of your logic is local to a single system, then you don't need a blockchain. If you have an application that requires a settlement process, in real life, if you have a settlement process that requires a trusted third party in real life, you might be able to make that more efficient on the blockchain by allowing the interactions to go through on the blockchain rather than in real life. That's what this refers to. And you'll see this when you build your escrow contract. That's exactly the target for something like this. So typically in escrow, you basically have to trust a third party to get the deed, to get the money, and then do the swap. You can do that much easier on the blockchain. That third party intermediary can be done much more easily in a blockchain system. Anything that needs integrity, authentication, and non-repudiation. And applications that have very precise rules. So we'll get to this with Ethereum. You need to be able to specify your business logic precisely in code. And those are the applications that you can then encode in a smart contract. Applications requiring transparency as opposed to privacy. So this will allow you to see that particular individuals have committed to certain transactions. Okay, so the first class of applications are the currency applications. This is what's basically popularized blockchains. So Bitcoin provided one of the first alternatives to fiat currencies. Modern alternatives, I should say. There's a lot of alternatives to fiat currencies. But it was basically, that was sort of it's the real contribution of, one of the real contributions of Bitcoin is that it upended the notion that we had to depend on fiat currency. So a lot of libertarians like this because fiat currencies decouple the supply of currency from a physical good. And so governments are controlling, so fiat currencies are basically, for example, the US dollar is a fiat currency, right? And the amount of dollars that are out there, the supply of dollars is controlled by the Fed, the US government. And they could basically print a whole bunch of dollars, and then if you hold, they can completely devalue your dollar based on whatever financial policy the Fed wants to take on. And so a lot of libertarians don't like that. So this is having a cryptocurrency where the supply of that cryptocurrency is bounded by a virtual good that's mathematically bounded is a way to attack that problem. Okay. Okay, so this breaks the status quo where there is control by the government of the amount of money that's out there. It's also being used for asset transfers. So whenever you transfer money internationally, so if I want to send money from the US to somewhere in Europe, it always requires a chain of banks. It requires my sending bank, an international clearinghouse, the bank on the other side, and all three of them have this chain of transaction processing that has to occur before you can actually transfer the money. And so with Bitcoin, you just get the wallet address and you say, send that person money, and it just works. So they want to emulate that in the financial sector. They want to be able to do these bank transfers as streamlined as simply sending something to an address. And so this is what they're using, a distributed ledger, where only banks are the writers. So if all of the processes for clearing that transfer are done on a blockchain, then you can streamline sort of the funds transfers. And this is being done on a permission blockchain. Okay? And so this is a recent example of it being used. So this is from January. So HSBC is already doing this in their business process. So 250 billion. And this is all currency transfers that they're doing electronically. And it basically has, I don't think the number is there, but it basically reduces the transaction costs on that transfer on the back end. Another application is loans and financing. So typically when you have a loan, you have the lending bank, you have the borrower's bank, and then you have the loan applicant. And all three pieces want to see the loan being processed transparently. And so one of the things that you can do with the blockchain is that you can have this strong identity and consensus so that you can see the processing happening and you can verify that, yes, these are the correct players as part of that loan application process. And so this is much more efficient than doing this manually. Having people show up in person, having the paperwork being handed off from person to person. And this was the basis for this IBM microfinancing project. So this is especially the case in a place like Africa, where the loan and the loan financing is done on such tiny increments that you don't want a physical person to be involved handling those loans. And so the idea there is that they're going to use a blockchain to sort of manage the financing. They want to implement microloans. And that's one of the things you can do when you have automated the process of lending money and of repaying the money using blockchain applications. And so they did this thing with basically small farmers. I forget the African country, Kenya. And so the loan duration was 4 or 8 days. So the farmer would need to buy something up front to help them harvest. And then when they sold the goods, they could repay that loan within 8 days. And because you have enabled that using a blockchain, you can get that person much more productive than they were before. They can rely on being able to purchase the things that they need to turn that profit to then repay it. So that's what this project is. You can click through on this link if you're interested more in that particular application. Okay, another aspect are asset transfers. And this, when I say asset transfers, I'm referring to non-currency asset transfers. So the previous one was about currency, but you could also think about transferring things like stock ownership on a blockchain, where the ownership is determined by these signatures and their transfers statements. And so this is an example of this, where you have this asset ledger on top, and then you have individuals signing their intention to transfer assets to and from that ledger. Okay. They have suggested these kinds of asset transfers on blockchains for anything else. Any other kind of asset, like real estate, fine art, equity, investment funds. And this is what this Harbor blockchain was trying to do. So the idea is that you could put deeds to a property on the blockchain and then provide public verification of who owns that particular property. So one of these scams that you might read about periodically is someone hosts an open house in a house where the owner is vacationing, right? And then is basically able to convince the buyer that they own the property and then get the money from the buyer, and then on the other side, the deed won't get transferred because actually the legitimate owner won't transfer that deed. So that, if you had a blockchain to be able to validate those deeds, that's the idea of something like this. And it doesn't have to be real estate. It could be any property that requires some kind of proof or verification of ownership. Okay. Intellectual property ownership. So digital content that you want to put your own timestamp on. What you could do if you have this great, for example, song. Say you created this song and you don't want to get it ripped off, but you also don't want to just publish it for everyone else to hear right now. Then what you could do is you could produce the song. You could take a cryptographic hash of that song, and then you could publish the hash onto the blockchain. And then when somebody decides, someone gets an illegal copy of it and then produces something and claims that it's their own, you can say, oh no, I have this cryptographic hash. It's unforgeable. Here's the song that validates to that hash. And look, it's the exact same song that you had said that you'd written. So that's one of the ideas behind something like this. GoChain is an application of that. Okay, and you could do this for anything like patents. You could do it for invention disclosures. Invention disclosures are a big one, right? Because if you have an invention disclosure, that has to go out to everybody before you even are able to patent it. And so this is something where you can commit to an invention disclosure without actually producing it for people to see and get the ideas from, if that's in fact what you want to do. Okay. Another big class of applications that people are building blockchains for are provenance and supply chain issues. You want to be able to track where all of your stuff comes from for your supply chain. So for example, conflict diamonds. You want to make sure none of them, like as a business, you don't want to be involved in, like if you're a jeweler with ethics, you're like, I don't want anything to do with conflict diamonds. I got to make sure that everyone who I source diamonds from participates in a blockchain where they're validating where stuff is being mined from. Where are they getting their diamonds from? And I will not buy any diamonds that doesn't have that chain of custody that can go all the way back to the mine that it got mined from. So that is what IBM was doing to basically get the authenticity of the resource to avoid that. Okay, so this is the Trust Chain Initiative. It's also being applied to retail goods. So fake Nikes, well, I don't have Nikes, but fake Louis Vuitton bags or Gucci or wherever the high-end, what's it? Supreme luxury goods. That's what I'm looking for. So that is a huge problem. This is like a $600 billion a year fraud problem. And so one of the ideas and one of the projects that IBM has sort of started is this crypto anchor thing. So you put a unique cryptographic tag on the product, and then everywhere in the supply chain that it goes, it submits a record onto the blockchain. And if you get a Gucci bag that doesn't have one of these things, you can't verify that it did actually have a train of custody in a supply chain that's been validated. And then you could say, okay, that's fake. And so that's what they're trying to embed in all the luxury goods. And even if it's cheap enough, these crypto anchors are like, they're like pennies to make. And they're pennies to include in a product. So these are things that you can weave into the product itself. And then you would be able to say, yeah, this is where all of this was the factory, this was the time that it was produced, this is the distributor that it went to, et cetera, et cetera. And so I don't have links to these articles, but one of the things you can do is if you see an article you want to read, just Google the headline, and then hopefully the news article that I pulled this out of shows up. I haven't been good at putting the actual links in the slides. I'm going to I'm going to try and do that more later. Okay, another big one is fishing. So we have completely overfished the oceans, and so now we have quotas, right? And if you're trying to ethically source your fish, so say you're like New Seasons, and you're like, yeah, I don't want, fish that was from some trawler that was basically violating all of the rules of fishing. So I want to be able to source fish from people who I can trace the quota all the way back to for that fish. And it has to be published. So every fish that this particular trawler has sold will be on the blockchain. And so you know that particular source can't overfish, right? They can't, if the quota is 100 and they try and produce 1,000, sell 1,000, you can see that the validation hasn't occurred. Like the validation of 1,000 fish is on the blockchain, and then they'll get either caught, or if they send you a fish that can't be validated, you're like, okay, I don't know whether or not that was a legitimately caught fish. And so by doing so, this is attempting to address the overfishing problem of our oceans. This is the entire system that they envisioned, where here you are right when you fish catch the fish, you tag it, and it gets uploaded to the blockchain. And then anywhere in transport and storage and processing and in shipment, you're also uploading these events. And when the restaurant at the very end gets this fish with a tag, it can actually validate, yes, it was actually sourced from someone who is, like, if you claim it's a sustainably fished specimen, then you better be sure you can verify that. So that's one way of applying a blockchain to do something socially good, which is pretty cool. Yeah, there's a pretty good video, which I'm not going to play. Another one is healthcare, so transparent medical claims processing. There's a lot of fraud going on in medical treatment, and so and you'll see this. Like, what prevents, for example, a healthcare provider from submitting multiple claims on different insurance? Like, so insurance companies, they want to make sure you're not covered by multiple insurance policies. So if you have a spouse, you're typically having to choose which insurance policy to use. And so what an unscrupulous healthcare provider could do is to try and double bill. And so if you have the claims processing done publicly on a blockchain, then you might be able to catch these issues where all the insurance providers will publicize all of the claims that are being processed. And then you might be able to identify double billing charges and these sorts of things, that kind of abuse. And so that's what this effort is intending to do with the blockchain. Another one is drug abuse. So if you're an addict and you're doctor shopping to get a bunch of prescriptions for your condition, then if you had this prescription database that's public, you can see that, right? And you can identify where this abuse is happening to prevent drug abuse of the opiates. Okay. This is one that I thought was interesting. Censorship resistance. So there is this was earlier this year, January 2019. There was this group that had basically compromised a whole bunch of sensitive 9/11 papers, I think was what it was. And they were trying to get paid to release these damaging papers. And so they had this fundraiser. They're like, send us 10 Bitcoin and we'll publish this set of documents. Send us 10 more, we'll publish the next set. They were being banned from all the social media platforms. Like Facebook is like, we want nothing to do with this. I mean, it basically goes against their terms of service, right? You can't be using the social media platform for illegal things. That was clearly illegal, so they got banned everywhere from social media, but they're trying to raise money, and so they're like, you know what? We're getting paid on a blockchain. We may as well try and publish on a blockchain. And so that's what they use. There's this Steemit service. It's built on a blockchain, and it's built to be censorship resistant, right? There's no central authority that you can go to that say, take down this content. You can't take down the Bitcoin blockchain, right? There's no central authority to go to. And that's the idea of this Steam It thing. It's a social media site that basically can't be taken down. And so, yeah, it's using basically a distributed blockchain of multiple providers to give you a censor-proof resistant social media site. So that's what they went to. I don't know if they actually got they got one level of Bitcoin and then they released some documents, but I stopped following this story after that. Another interesting application is identity and reputation management. So when you buy something on Amazon, you get the chance to review that product, and it says Amazon verified, right? Like they can actually verify that review, or like when you review a vendor, for example, they can verify that yes, you actually had a transaction with that person. If you wanted to do this across all sorts of different websites, then that's what this idea is. You could basically put your identity and reputation management stuff on a shared blockchain. So this is a picture of it. You have all these transactions, and then based on whether or not these things went well or didn't, then you would upload a score on these participants, and then this is the thing that would be open for everyone to see. You could see all of these votes. It's sort of like a little bit like LinkedIn. It's like a public sort of score for the different transactions that people have done with each other. National ID systems and elections. This is also being proposed. West Virginia allowed expats, I think they were expats in Europe, to vote via a blockchain. Now there's all sorts of issues. I'm not saying this is secure or recommended, but this is what people are doing. Is applying there's a push to run elections on blockchains. There's a lot of landmines with that, but that's one application. And then there are certificates. So recording certifications, licenses, and degrees. So for example, AWS certifications. You want to be able to, so if you get a resume and it says, oh, I have this AWS cert, like you want an easy way to say that yes, AWS has blessed this person as having passed that certification. That could be done via a blockchain. Now, AWS is not a good example because then that's a central authority that you might as well just query directly. But say we had a blockchain for all sorts of certifications that people could mint, then you could just check that one source. Okay. So yeah, digital diploma at MIT, that's using that. Okay, I'm going to finish off with an adversarial analysis. Blockchains are no substitution for security. And it's important to look at how the blockchain is being managed because it's basically an issue of garbage in, garbage out, right? Like if your garbage is being logged to the blockchain and someone queries it, it's still garbage, right? And if you start trusting the garbage, then you've got a problem. So the example that they show is the one for this fish, the fish supply chain tracking. One of the things that they wanted to log on every step in that supply chain was the temperature of the fish, right? I got to make sure that fish isn't spoiled or has been, in 90 degrees for any point in time in its transfer. So the intended scenario is that, yes, there is a refrigerated truck here, and the tag of the fish is measuring the temperature that it's being stored at, and it's all fine and good. But in fact, the tag itself could be refrigerated and the fish could be outside. And because you haven't considered an adversarial analysis, which most people don't when they're using a blockchain, you end up with an issue here. So yeah, here's another one, expensive bottle of wine. You just empty out the contents and drink it and then fill it back up and it's still got that tag. So yeah, that's not a substitution for security either. All right. It's also not good if all you needed is a signature. So like that certification one, all you needed was AWS's signature on that particular person's certificate, and then you're good. You didn't need this whole distributed agreement thing on the back end. The one exception is if you need a reliable timestamping method. So if you want to timestamp your signature against a whole bunch of other events, then you could use a blockchain for that. Like everybody knows when block 2 million was mined on Bitcoin, and if your transaction was part of that block, then you have a timestamp on your transaction that's tamper-proof, basically. And this is like so you need to bootstrap this, right? So this is one of the articles said the bootstrap on one of the blockchains was a picture of the newspaper article at the exact time that the first block was mined, so that you knew that the mine was the block was mined at least after that headline was shown, because they timestamped the image and they uploaded the image to the blockchain. So that was their proof of time. Okay, it's not good if you need a regulatory piece. So if you have some authoritative party that needs to be able to overrule certain transactions, then you can't use a blockchain, because it's sort of meant to not have that. And so things like, for example, any agency for land management, for example, has to be able to overrule certain kinds of transfers. So already you're running into this piece that requires you to go off of the blockchain. And then you would basically just use a regular database where that particular authority runs it and makes sure it's tamper resistant. You wouldn't be able to use a blockchain for that. Another one, even though initial coin offerings are a very common way to raise money, if you think about it, it's really hard to hold the person raising the money accountable to the investors, right? Like, you've given all this money, but if the person, and this has happened, if the person just takes all your money and runs away with it, then there's no regulatory piece for you to get that stuff back. And so this is where maybe fundraising on a blockchain might not be suitable for you. And then if you do have to have a regulatory piece, well, then that regulatory piece basically is your trusted authority. So that's a problem. Okay, so with all of that, your first set of labs are Hyperledger Sawtooth, and these are Python labs. And I want to give you an overview of these labs.